All right, we're all set up to weld. Let's just talk about a couple quick things here. One of the biggest issues people run into is how much stick out they run. So this contact tip, this copper colored piece here, is what transfers electricity from the welder to the wire. At this point is where that happens. Well, the distance between the tip of this contact tip and the wire where the molten pool is very critical. With short circuit MIG with gas, you have a lot of leeway. Generally you want it under 3/8 of an inch, but you can run it too long, too short, and you don't really have too many issues. Well, a flux core wire, if you run it too long, like say, that's like 1.25 inches or 1.5 inches, too long, and well, your weld's just going to produce a ridiculous amount of spatter, which is no good, but you're not going to be able to produce a decent weld. Now, too short, like that, which is about 1/4 of an inch, if it's too short, you're going to get what's called wormhole porosity. This wire needs time between the end of the contact tip and the weld pool to heat up, to turn the flux that's inside of this wire to gas. If you run too short of a stick out where this tip is jammed up real close to your weld, what's going to end up happening is the flux is going to turn to gas in your solidifying weld pool, where it's turning from molten metal to solid. And then as it's doing that, the gas is going to escape and push that weld open, and you're going to see like what's known as wormholes, where it's a big long channel or holes that are like just all over the weld. That's typically only found in flux core wire. Well, that's generally what causes it. If it's not a bad spool of wire, it's going to be an issue with your contact tip distance. So the proper distance at a minimum is 1/2 inch, and this is actually probably about 1/2 inch, maybe a little bit short, to 5/8. So this is closer to 3/4, so a little bit under this. You get the idea, 1/2 inch to 5/8. You must maintain that distance in order to get the wire properly preheated. The other critical thing with it is when you're welding, you do a drag angle with flux core. So you're pulling it like this. So the gun is getting pulled like this. You do not push where you're welding like this. The reason for that is you're going to entrap slag in front of your weld pool, and your weld is just like anything that produces slag. The old saying, if it makes slag, you drag it. That's pretty accurate. So you want to have a drag angle, and your contact tip to the molten pool distance, a little bit shorter than what I got here would be ideal. Now you can go somewhat straight in like this if it's a horizontal joint, or vertical, okay? But you never want to start doing this. Your welds are going to suffer for it. Let me throw my hood on, and let's run our first bead. I'm going to let this play in real time rather than fast forwarding it. And I want you to pay attention to how slow I'm actually progressing forward. I'm not really moving fast, and that's one of the biggest mistakes people make with flux core, is you want to move slowly. If you move too fast because you're burning a hole through the material, then you need to lower your settings so you don't burn a hole. Now, if you look at that glowing orange, we're running a little bit too hot, which I kind of suspected. The previous one to this that I had ran a little bit on the colder side, so I'm going to drop the voltage down a little bit to E1/2 and nudge the wire feed just a little bit lower. And this is obviously a little bit too hot to hold, so I'm going to grab it here. Let's talk about what we see here. So first off, if you look, the weld is covered with a good coating of flux on there. We cannot see what the actual weld looks like based on this appearance, which is why it's so important anytime you're welding and learning how to weld with flux core, wire wheel it with a grinder or use a brush, clean all that crap off of there. Like, how do you know what it looks like under there? So the second thing is, just by the appearance of this, I know that the weld's going to look decent. The reason is the flux is equally distributed on there. I don't see any like mountains or excess spatter. Most of the spatter will just brush right off. Not too worried about that. We can tell it was run hot simply because look how wide this is. And then when we were done welding, half of it was still glowing red. So really, a little bit too much heat. Let's flip it over. Now this is just scrap. I don't see any melt through, but I did weld right on top of the scrap weld. So nothing too unsurprising there. So what I'm going to do is I'm going to let this cool. I'm going to buff off the weld, and then we'll look at it cleaned. All right, I cleaned it all off. Just take a look here. Now, there's quite a bit of hard spatter. Our settings could use a little bit of work, and a lot of that'll clear up. But the weld itself doesn't really look that bad. Overall, it's a decent width and height, fairly consistent. You can see the start's cold, which with these flux core wire welders that don't have like a adjustable initial feed speed, I mean, this is as simple as you can get, you're gonna have cold starts. Because if I set the machine hot enough to have a good start that isn't on the colder side, then the whole weld's gonna be too hot. Not really a whole lot you can do with that. But like I said, the spatter we can take care of in settings and we can lower the amount. It's also worth mentioning I'm using Harbor Freight's flux core wire. That's the only stuff I could come up with. I picked this welder up earlier tonight, and Harbor Freight was the only place I could find flux core wire at. The local Farm and Fleet, which is kind of like Tractor Supply, they didn't have any in stock that was 030. So my guess is that Harbor Freight's wire is going to have more spatter than the competition. I mean, in my experience, pretty much anyone else's wire runs better than Harbor Freight's. So now that that's kind of cooled off and cleaned up, I'm going to run another pass. We're going to look at it after I clean it up, and then we're actually going to weld some test joints and look at them. So I want you to pay attention to the sound that this makes, and I'll shut up for a second. That's about the sound that it should be making for you when you're welding. Now this is a little bit too hot, so the sound will change in the later clips, but this is what you're aiming for. If it doesn't sound like this, something's wrong, like you're probably going too fast or your settings are off. All right, so wire wheeled it. Spatter is a little bit less. A lot of this was just already on there. You can see a little pin dot of porosity right there. But overall, let me get this a little bit better in focus. You can see pretty decent weld. Spatter issue, we'll have to weld on clean metal to really look at that. Like I said, I'm not a really huge fan of Harbor Freight's flux core wire. I would highly recommend using Lincoln's NR211, I believe it's called, inner shield wire. That is a much better wire than Harbor Freight's. But let me go cut some more steel and let's do some practice. So we got a bunch of test pieces. It's 1/8 inch thick steel, 5 inches long, I don't know, 1.25 inches wide or something. We're going to be welding these up in test welds. A couple things I want to mention. One, after I'm done welding, so I'll run a pass, wire's done, I'll take and break it off, just twist it, just like that, and then feed enough out to where you have your about 5/8, 1/2 inch stick out. You always want to start on a clean tip rather than what was left when you were done. And the second thing is I found that the contact tip that I screwed back on, I must have forgot to tighten it up because it was a little bit loose. So I snugged that up. That will also change how your welder's welding, so there may be a little bit of a difference there. So we're going to start out and we are going to weld a lap joint. Now I'm not going to prep this material on purpose, and we're going to look at it and then I'm going to weld one, same settings on prep material, and see if there's a difference. So on your machine, I'm going to open it up and look at the settings. E1/2, 6, so I got it on 6, and I'm going to bump it up a little bit closer to F than E1/2. And that's going to be where we're going to start. And I will set it right there. Let me get my hood on. All right, so I'm going to tack it in the corner here and on the corner there, then I'm going to flip it over and weld the other side. Oh, look at that. First mistake, left the sticker underneath there, didn't even see that. I guess we're going to weld it on this side and just burn the sticker off, which will definitely cause porosity issues in our weld. All right, so let's weld it right here. I'm going to put this piece just to kind of help hold it. I want you to pay attention to the angle that I'm welding at. As you can see, I do still have a drag angle, but I'm kind of pushing more towards the top plate and a little bit into the bottom plate. My angle could be a little bit better on this, and you're going to notice when I'm done with this weld that the toe on the bottom is a little cold, and my travel speed was a little bit inconsistent. But overall, for a first weld with this machine, not bad. All right, we're going to let that cool off. Had a little bit of a rough start. The arc kind of killed out a little bit. It seemed to be a little bit on the hot side, but it was kind of hard to tell. This wire definitely runs a little different than I'm used to. Overall, we don't really see much hard spatter on this, which is a good sign. The flux seems to be equally distributed. The weld width, from what we can tell, seems to be pretty consistent in width. So those are all good signs. I'll let this cool off and then wire wheel it up. All right, so we got that all cleaned up. Now, if you look here, a little inconsistent on the travel speed. The spatter's much better on this, almost no hard spatter. I think I can go a little slower on the travel speed on this and it'll improve it, it'll flatten it out a little bit more. There won't be so much of like a necking down stepping. Now on flux core wire, I tend to do a little forward progression, a stop and a forward, kind of like this. For me, it just seems to run a little bit better. If I just go straight in and just like this, it seems to me like it tends to create more spatter. Could just be me though. This is similar to like a cross between 60-10 and 70-18 rods. So when you're welding, whatever movements you make are captured in your weld. So it's similar to 60-10 that the puddle freezes fast, but it's not quite as like fast freezing as 60-10. So it's really kind of like a cross between 60-10 and 70-18. I buffed that sticker off here. There's probably still some in there, and it may create porosity in this part of the weld here. We'll have to see. But I'll give this a minute to cool down, and then I'm going to weld this side, and then we're going to take a look at it. I'll go a little bit slower So that should produce a little bit better of a weld, but we'll go from there once this cools down. That seemed to run really good. I don't anticipate too much hard spatter on it, but again, without even seeing the weld, just look at the darker color that's right above our weld. Very consistent in width, evenly distributed. When you guys are welding, you're going to notice if you're traveling too fast, instantly when you're done, you'll see this black Flux coating is going to neck down. You might see some of the weld exposed, or it won't be nice and flat and uniform like this. Great indicators that your weld, you're just traveling too fast. I'll give that a minute. It's pretty hot. I'll let it cool down, and then we'll clean it up and look at it up front. Let's take a look at what we got here. There we go, much better looking. So if you notice, it's more consistent than the previous bead overall. Got a little thin right there. There's almost no spatter on here. I mean, there's a couple pieces that I'm sure a chisel would pop right off. The toes actually are a little bit cold almost on the bottom. I had an angle on this. I was coming in like this. I probably could have tipped it a little bit more upright, which would have drove it into the plate a little bit better, the bottom plate. But overall, that's going to be a very sound weld. And I guarantee you the penetration, if we were to cut this open, you're going to see really good penetration on the inside of this, which is exactly what you want. But overall, not looking too bad. So now I'm going to do a test weld where I'm going to clean some plates, and then we're going to do a lap weld, same settings as I've been using, which is about E 3/4 and 6 on this machine. And we're going to look at what it looks like on completely clean and prep material. Maybe it's going to make a difference, maybe not, but we're going to check it out. So we got our plates much better prepped. I mean, that other plate set, I didn't prep anything. So we got them all cleaned up. I will tack them in place. Actually, I'll do it this way. And then we're going to do some test welds and just see maybe they weld better, maybe they don't. This plate had a very thin, like you look at this, very thin mill scale. Like, I mean, it's almost wore through here. When you're dealing, might have been cold rolled. I mean, maybe not, but when you deal in thicker plate, like 1/4 inch and thicker, as a matter of fact, I'll grab a piece of it over here just to give you an example. This is definitely hot rolled. This mill scale, you definitely want to clean off. Like, I know that you can't TIG weld on this, but stick welding and pretty much any welding on this, if you can prep it, do it. Your welds will come out cleaner. But this stuff really doesn't have that bad of a coating on it. So it probably isn't going to make a huge difference, but we'll find out. So this pass, I really slowed down my travel speed. I noticed that my weld seemed to be a little bit underfilled per se, so I just let it fill. And you can see I'm moving forward really slow. You want to get your settings, especially on 1/8 inch material, where you can progress slow like this. and not burn through. And the settings that the machine recommended for this thickness are what I'm running, and overall they're pretty close accurate to what they should be. All right, I had, again, like 3/4 of an inch in. That was my finger coming off the trigger a little bit. I didn't hold the gun that good, but overall looks similar to our last test weld on a little bit less clean steel, consistent flux coating. Again, everything's looking pretty good. I'll let this cool off, we'll wire wheel it, we'll look at it, we'll run another test weld. You guys get the picture. Now let's take a look. Actually a little bit more hard spatter on this, surprisingly. It's probably just sticking to the metal more that it's clean. But again, overall, the bead is pretty equal in height and width. You can see where I restarted because my finger fell off the trigger. Kind of a little bit hard to hold that down sometimes, it seems. But overall, pretty equal in width and height. Yeah, not bad. I'll shoot a side profile for you. I'm going to end up doing a cut and etch of these as well, so you'll see that. Yeah, not bad. I don't see any evidence of porosity or wormholes or anything, so I think we're pretty good. What we're going to do now, I'm going to weld the back side of this, and then we're going to go on to doing some fillet welds. While this is cooling here, I'm going to give you guys a couple other tips. Angle-wise, you don't really want to come in straight up and down like this. What's going to happen is that root of the joint where the two pieces meet down in there, you're going to end up likely bridging that. So you want kind of an angle more like this to where you're hitting in there with the root. So somewhat from here to like maybe here. Now on thick plate, you can run flatter, but ideally, if you want to favor any piece, generally speaking, you want to favor the, on a fillet weld, the upright piece, because the weld pool will want to tend to settle a little bit lower. On a thicker steel in this lap weld, you're going to find that if you come in here at just a straight 45, your weld's probably going to be a little more on the bottom piece than on the top. All right, that's at least cool enough to weld. Let me run another weld on this. And actually this one, I'm going to lay flatter. Well, I guess I'm just going to do it at 45. Another good run, same deal as before. You can see all the indicators that odds are what's underneath there is going to look pretty decent. We'll let that cool off, clean it. All right, let's take a look. Definitely some more spatter on the lower piece than before. But that weld is real good looking. So since this plate was still a little bit hot, you can tell the toes of those welds, that weld is definitely flowed in pretty good. Had a little bit of a whoopsie there, but again, overall, now you can tell by this bead appearance. If you look here, it's a little bit more humped up, you can tell. A little bit more defined like ripples, and then when you come over here, it's overall closer to like a 70-18, smoother. And that's because this plate was preheated, therefore it flowed out better. But that's ideally what you should be shooting for. Now I pretty much went straight in, I did not oscillate at all. So you can see you can run it that way, but overall, not too bad for a $170 welder. Let's get that out of the way. The last test weld I'm going to do here, I'm going to do a standard fillet weld, and I'm not even going to bother to prep these plates. It seems to be welding pretty good. I mean, honestly, I can't tell much of a difference. If anything, there might be more hard spatter on the cleaner plate. But you look at these, one on my left is prepped, and this one, I mean, there's more spatter on both of them that were prepped. So I think it's just a case of it sticking to it better. You can always use some kind of a anti-spatter spray. That stuff works pretty good as well. So let me get this tacked up as a fillet weld, and then I'm going to talk about that a little bit. All right, so I got our fillet weld tacked up. Now, this is going to take a little bit different heat than the lap weld. I'm going to keep the settings on this machine all the same, just so we can see where they're at, but we'll probably notice that on this weld, it's going to be a little bit colder looking than a lap weld, and that's because this top plate can pull heat out from the weld this way, and the bottom plate can pull it this way and this way. There's basically more metal in more directions for the heat to travel to be pulled out of the weld on this than on a lap weld. So we should see a slight difference. But overall, like I said, we're still using the same settings, E and 3/4 and 6. And we're gonna weld this much the same. Now, gun angle, you don't wanna go like this, because you're gonna weld into the top plate, probably undercut it some, and then the bottom's not going to have enough weld. Just like you don't want to weld like this, you're going to cut into the top plate. I would recommend take a 45-degree angle, tip it down some. This is about the angle you want. The hotter you run, the more you're going to have to angle down, or you're going to just have the puddle sit on the bottom plate because of the heat. Now for gun angle, you don't want to really weld it like this. In this case, I would suggest something like this. You can technically weld it as back far as this, and it probably will weld, but you're going to find like a natural, just like that. That should be pretty good. Stick out again is going to be the same. That's pretty close to 5/8, half-inch 5/8 stick out. So this is about what you're going to be looking at. If you push that in too far where you're like this close, you're going to get wormhole porosity. And to show what that looks like, when I'm done with this, I'm going to actually do a couple welds purposefully bad just to show you what they look like. So let's get welding here. Might be a little hard for you guys to see simply because camera zoomed out. But at the end of the weld, only about a ½ inch of it was glowing red, which that's a very good indicator. As soon as you're done welding, if half of the thing is glowing red, too hot. If only a little bit is, that's ideal. And if you look here, this thing's still hot as a $2 pistol, but very consistent flux coating. It just looks like whatever's under there is probably decent. At the end of the weld, it's pretty common for the flux to just fall off on its own, so not a big deal. Well, that's cool, and let's look at the back side of it. So we don't really have any penetration by the look of it. There is like a coating of the mill scale that kind of cooked off. That's what's hanging off there. That's not weld, it's just the mill scale burned off. But no penetration out through the back. Let me brush that. Yeah, I mean, you can see it peeking through there a little bit. I mean, we're on right there. If we really, on this thick a plate, had I turned up the heat a little bit more, we could have burned through all the way. but a better idea would have been just to run a gap. But I mean, that's right there. That's what you want to see. So I guess I'll wire wheel this and we'll see what's underneath there. Let's take a look. So overall, pretty much looks like a stick weld, doesn't it? Now the spatter only collected on the bottom plate, and I'm sure all of that would chisel off. None on the top plate. But yeah, I mean, it pretty much looks like a stick weld. I'll try and get a angle here. Maybe a little bit concave. I can bust out a fillet weld gauge set, and let's take a look at where we're actually at. Sucker's still hot. I got a 1/8 inch fillet weld gauge. So 1/8 inch is apparently on this side right here. So let's start out by looking. So our weld, if I can get that to focus, is good in that direction. If I can get this guy to focus, let's see here. You can see it also hits right where it should there. Let's check throat depth. I don't see any light under there, it's touching. So yeah, we pretty much nailed our ideal weld size, being that this is 1/8 inch thick. The weld is about an 1/8 inch up, an 1/8 inch onto this plate, and then the depth of it is an 1/8 inch, plus it has penetration through the back. So our weld, this is definitely a very strong weld, and this is what you'd want to deposit on this stuff. Again, I'll bring that up a little bit. I'll weld the back side of this too, just to get a little bit more practice. Realistically, when you weld on the back of something like this that penetrated through it, the weld quality is not going to look the best, honestly, because we're welding over like mill scale and stuff we can't clean out on the inside of that. But I'll weld it through it anyways, and we'll take a look. Well, that's cooling off there. I just thought I'd talk a little bit more too, because again, I love talking, as you can tell. What I'm looking for when I'm welding is there's like a round molten puddle. You can tell it looks different than the area behind where your molten puddle is, because it'll be brighter and sort of appear liquidy. And all I do is I take that round puddle and I just slowly drag it along the weld. So like say this is your weld, I just slowly drag that puddle. If I pick up speed too fast, it's gonna go from like this round puddle to looking like this, or it might just disappear completely. You're going too fast. You wanna let it stay the same size, same shape, and just drag that shape along that round puddle. With 7018 stick, you have like an eye shape that's shaped like this, like an eye. But with Flux core, you're looking more or less for a round puddle shape, and just drag that molten puddle along nice and slow. And you can tell because I didn't speed up the welding process, just by the look of it, you can see how fast I'm going. I'm going slow. I'm not going fast. If you go fast like this, you're not going to deposit the weld you should be. Let's clean this up. Quick cleanup job. You can see there's still some flux in the toes there that could easily be cleaned out. Again, spatter on here. I'll blame the wire. Maybe a little bit of the settings could be changed. But overall, yeah, that may come out. Oh. Overall, not too bad. I'm just going to do a couple test welds just to show you what bad looking welds look. So I'm going to set this at D6, and we're going to try and make a weld on this and see what it looks like. So even though it's a short weld, if you notice, there's a ton more spatter that's already present. And if you look at the weld has this weird white appearance, more so than the black. Let's see what's underneath this. So overall, still a weld. It's not that bad, really. All right. Let's go run another one, and I'll change the settings even lower. Let's go to B6. Now you could probably tell by the sound of that something was a little bit off. Didn't sound consistent. And now look, see how that flux, white in color, how it's peeling off of the bead? Like something doesn't look right. We can almost tell that weld underneath there is not going to look good. But let's clean it off and look. All right. So overall, I mean, it actually looks like a bead, but you can tell how humped up that is. Look at how wide this is, decently wide, and then you look at this and it's just roped up. So we need more heat. If your bead looks roped up like caulk, add more voltage, which is your A through J setting. Add more voltage if it till it gets wider like this. And there's no change in wire feed. We're still running the same wire feed as we've been this whole time. So now what I'm going to do, I'm going to run higher voltage and too low a wire feed. So I'm going to run 3 on the wire feed, F on the voltage. So looking at that, looks like a hot mess. Tons of spatter. Let's clean it off, take a look. Yeah, it's just spatter. I mean, there's a bead there, but pretty ugly looking. If you actually tried to weld two things together and not just a bead on plate, you would have had a pretty terrible looking weld. The last thing I'm going to do, I'm going to run too short of a stick out with proper settings, and we're going to see what's going to happen. So on this case, I'll run E 3/4 and 6. Same settings we've been running, and I'm going to run a really short stick out, and we may see wormhole porosity. We'll find out. Now you notice with a shorter stick out, this is the same settings I use for this lap weld, same settings for the fillet weld. The distribution of the flux looks off. Now part of it is more heat was going into the weld with the shorter stick out, but something looks off about that. So let me clean it off and let's see what we got. All right, and we do have some, might be hard to see. Right here, I guarantee if I ground that down, that whole area in there is basically going to be like a cavern, but there's some wormhole porosity in there. Overall, less than I would have surprised. I'm surprised it's less than what I would have thought, but yeah, you can tell real flat, real wide, ran too hot, and starting to get the signs of the porosity, so our stick out's just too short. Well, time to finish this video up. Figured I would just do a recap. What did we learn today? A whole ton of stuff. And what are you gonna do for me? You're gonna go in your shop or your garage and your basement, provided you're not gonna set your house on fire, and do a bunch of test welds. So if you pick up one of these welders or you got something similar and you're running flux core wire, best thing is honestly, run bead on bead on bead on plate until you can get like consistent beads to where they all look good. Much like I had on this, so just run bead on bead on bead on bead all day long. When you can do that good, switch to doing lap welds. When you can do that good, switch to your fillet welds. And about 30 hours of practice, maybe 2 spools of wire, 3 spools, you'll have this down to where you'll be doing really good. You'll be able to build a lot with this. And like I was saying at the start of this video, flux core wire has a really bad reputation and it's really undeserved. If you get a decent welder that is DC output, you can build a ton of stuff. Yeah, you might get some spatter, but beyond that, like you can make very strong welds. And as a matter of fact, as a bit of information, flux core welding actually has more penetration per amp than short circuit MIG. So on this machine, which is 125 amps, you can safely weld maxed out roughly a 1/4 inch thick steel and still have adequate penetration. With short circuit MIG at 125 amps, you could barely weld 3/16 thick steel and have proper penetration. When you're dealing with your 140 amp hobby welders that a lot of you guys I know have, you can actually weld just over 1/4 inch safely with flux core wire with those, and those machines 140 amp will not weld 1/4 inch thick steel with adequate penetration with short circuit MIG, with gas MIG. You can make a weld on it and it would look like a weld, but if you were to cut and etch it, the end result would not be good. Like you wouldn't have root penetration, root fusion. But yeah, that pretty much covers it. If you guys have any questions, comments, want to see me do another video with this machine to cover a specific project you got, I'm more than willing to do that. Ultimately, I'm going to shoot a couple more videos with it, and then prior to Christmas, I'm going to give the machine away to you guys out there because I don't really need it as much as I'm sure some of you do, because I don't do that much flux core welding, but I wanted to do a video to help you guys out, so I bought one. But like I said, look forward to that. Within 2 weeks, I should be giving it away. I got a lot of stuff going on behind the scenes here that I got to deal with, so it's within a couple weeks I'll be doing a giveaway for it. I definitely want to get it to somebody before Christmas. Anyways, thanks for your time. Let me know if I helped you out. Thanks.